take a little while, so let's just push through them. We would like to graph y equals 3 cosine of x plus pi over 4 over 1 period. So we're going to take some time and we're going to like pick this apart and see what everything means. So I know that the a value in this case is what? 3. And that means that my amplitude is 3. The b value is still 1, so my period is what? 2 pi over 1, yeah. The c value is still 0. We still haven't done one yet that has a vertical shift. So c is 0, we have no vertical shift. And the d value is positive or negative pi over 4? Negative pi over 4. And that gives us a phase shift of left. It goes to the left pi over 4. So we're going to try to do this right and make enough room up here this go round. Okay. What should I make a table for first? Y equals 3 cosine 1x. So you ignore c and you ignore d. You just look at a cosine bx. So that's what I'm going to make my table for. So I'm going to come here and make a table. And I'm going to start at 0 and go up to my period, which is just 2 pi, right? So 2 pi. So these will still be pi, pi over 2, and 3 pi over 2. And then, did you guys memorize yet the pattern for cosine?
Yeah, it
starts at
0, negative a, 0.
A, 0, negative a, 0, and back to a. So if you haven't memorized yet, that makes it a little bit harder. But remember that you can just plug in. Cosine of 0 is 1, and 3 times 1 is 3. The cosine of pi over 2 is 0, and 3 times 0 is 0. And usually once people can get those first two, they'll remember the pattern after that. So there is our table for y equals 3 cosine x. Now I need a shifted table. So my shifted table, I'll do in red. And this is where I'm going to shift it to the left
So it's x minus
pi over 4. So that means I need to subtract from each of the x's pi over 4. Okay, so what's 0 minus pi over 4? Negative pi over 4. Okay. What's pi over 2 minus pi over 4?
negative pi over 2.
Just pi over 4.
Yeah. Pi over 2
Oh, yes,
minus
it's
pi over 4 is pi over 4 because 1/2 minus 1/4 is 1/4. So this becomes pi over 4. What is pi minus pi over 4?
3 pi over 4.
3 pi over 4. And what is 3 halves minus 1/4?
5 pi over 4.
Anybody know? You may have to go off to the side and do that one. 3 pi over 2 minus pi over 4. It's a common denominator of 4. So we'll double this one and get 6 pi minus 1 pi. So you're right, it is 5 pi over 4. And finally, for our last little piece, 2 pi minus pi over 4. So 2 pi is 8 pi over 4 minus 1 pi over 4, which brings us to 7 pi over, uh-oh, I don't know what happened there. I think I just got in a hurry. Okay. 8 pi over 4 minus 1 pi over 4 brings us to 7 pi over 4. So there are our adjusted x values for our new table. And the good news is they're all over 4, so we don't have to worry about that whole common denominator scale thing that we had to on the last one. Now our y values didn't change because we do not have a vertical shift. So this will stay 3, 0, negative 3, 0, 3. And then we'll come down and we'll graph that. Okay. So I need a negative pi over 4. I need a, oh man, not doing so well today. Positive, that would be negative pi over 4, 0, 1 pi over 4. 2 pi over 4 isn't going to be on there. Am I going to need 2 pi over 4? So I'm not going to label him. We are going to need 3 pi over 4. Do I need 4 pi over 4? I'm going to leave a dot for him though. 5 pi over 4? Yeah. Will I use 6 pi over 4? No. But I'll still leave a little space for him. And then I'll get to 7 pi over 4. So this one was a lot easier to count out because we didn't have to worry about the whole common denominator thing. All right. Now, let's put some dots on. Negative pi over 4 goes to positive 3. Positive pi over 4 is back to 0. 3 pi over 4 is negative 3. Five pi over 4 goes back to 0. And 7 pi over 4 goes to positive 3. So we can see that that cosine graph that we're used to seeing has indeed been shifted. Normally, where would it be?
Starting on the.
Yeah, it would start right here, and then it would hit all of the others. So it's been shifted to the left, right? Correct? Okay. Let's pause. Okay, so here's one other thing I wanted to show you on this example. If I graph the blue table here, or I don't know if it's blue or purple, I can't tell, I think it's purple. It would go through 0, 3, pi over 2, 0, pi negative 3, 3 pi over 2, 0, and 2 pi would be right here, right? You guys, it would be 8 pi over 4, and 2 pi, comma 3. So if you look at that graph, can you see that it's exactly the same as the other, but every point has been shifted to the left by exactly pi over 4 units? So you can see the relationship between the two graphs. Some people like to graph them both, and they will graph, like you're using a pencil, they'll graph the blue table dotted and the shifted one solid. I think it just gets busy. So I'm okay if you only want to graph one, regardless of what your book says. I just graph the final one. I usually just build the table for both, but I only graph the final. Okay, for this third example, we have to be really careful because the 3 is inside the parenthesis, and you're not allowed to have a coefficient of the x inside the parenthesis, so you have to factor it out. So the first thing we have to do is rewrite this as y equals negative 2 cosine of 3 parentheses. And when you take the 3 away from the x, you're just left with x, but when you take a 3 out of pi, you're left with pi over 3. Now that's called forced factoring. So whatever you take out, you just stick whatever's second there, you stick it over that. So you forcibly factor that 3 out. Make sense? Okay, it's really weird, but that's how you do it, and that's how your book wants you to do it, so just do it. All right, let's go off to the side over here, and let's identify A, B, C, D. In this case, A is negative 2. What does that make the amplitude?
2.
B is
3.
3. That's not going to be pretty because that makes our period what?
2 pi over 3.
2 pi over 3, and that's always my least favorite when it becomes something over 3 or 6. C is still 0, so we have no vertical shift. We are going to do one soon, but they're the easy ones. And D is positive or negative pi over 3? Negative. It's the opposite. So negative pi over 3. See, if you forget to factor out the x, a lot of people miss that, and they say it's negative pi, but it isn't. You have to factor the x out before you can see the phase shift. Now, some people look at it this way, and they say the phase shift is whatever makes the parenthesis 0, so here it would still be negative pi over 3. But you can see it better after you factor the 3 out. So that gives us a phase shift of left pi over 3. Got it? Okay. Let's make our first table. For the first table, I'm just going to make a table for y equals negative 2 cosine of 3x. We're going to ignore the d for now. We're going to make that table. Starting at 0 and ending at our period. What's our period? 2 pi over 3? Oh, not pretty. Okay. Yeah. What's halfway between 0 and 2 pi over 3? 1 pi over 3. Half half again,
Pi over 6.
pi over 6. So let's see if we can count this off. That's 0, 1 pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2, yeah, so that should be pi over 2. And that would be 4 pi over 6. So that would mean that it's 2 pi over 3. All right, let's fill in our table. For cosine, it always starts at a, and our a value is -2. Then it rotates to 0, +2, 0, back to -2. So pretty easy to fill in the y's if you've learned the pattern. If you haven't, not very much fun at all.
So you can memorize
The y's.
or like whenever the period is 2 pi over 3, you can memorize that it's pi over 6, pi over 3, pi over 2 for the
You're welcome to memorize that, but there's no guarantee you'll ever memorize all of them. You know what I mean? But they do get very familiar. So, are we good? Okay, well now we have to take that and we have to shift the values. Which ones are going to change? The x's or the y's? X's, how are they going to change? We're going to subtract pi over 3 from each of them. And then our y's are going to stay the same. Okay, let's see what we have here. What's 0 minus pi over 3? Alright, so we're over negative pi over 3. What's pi over 6 minus pi over 3? We don't know. Let's see. Pi over 6 minus pi over 3 is 1 pi over 6 minus 2 pi over 6. We convert that. So it's negative pi over 6, which is bad because that means we're going to have to get a common denominator to do our scale. Then we have pi over 3 minus pi over 3, which is nice because that goes to 0. And then we have pi over 2 minus pi over 3. We'll convert those both to 6's. So that's 3 pi over 6 minus 2 pi over 6, which is positive 1 pi over 6. And then finally, we're up to 2 pi over 3 minus pi over 3, which brings us to 1 pi over 3. And our y values don't change.
Can we also use the pattern like the negative pi over 3? It's also like reflected. Like it's negative pi over 3, the negative pi over 6, and 0, but then it's positive pi over 6.
Not always, because it doesn't always hit 0. It just depends on what the shift is. But if it does hit 0, then yes, because your scale will be the same. What's our scale in between each one of these? How much is in between them?
The pi over 6.
It's pi over 6, right? Yeah, they're going up by pi over 6 each time. Look, this is negative 2 pi over 6, negative 1 pi over 6, 0 pi over 6, 1 pi over 6, 2 pi over 6. There's always a pattern and a scale there, so once you establish it, you usually get a little more comfortable. Now, unfortunately, they want us to graph this over 2 periods. So we're going to put these over 6's. We'll make it pretty long, so we have some room to extend it. Okay, so we're at 0, and we're going to go positive 1 pi over 6. 2 pi over 6 is pi over 3. What would 3 pi over 6 be? 4 pi over 6? 5 pi over 6? Do I really have to keep doing this? 6 pi over 6? Why not? I'm beyond my table already, right? I just thought it would be fun. Oh, let's do one more. What would the next one be? Look, 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, that would be 7 pi over 6. Do you see how to extend your table if you need, or your x-axis if you need to?
I thought it went through 7 pi over 6.
It might, I don't know. That's not in my table.
Oh, okay.
That's just pi over, that's 1 pi over 6 and pi over 3. Let's extend out to the negatives. I need negative pi over 6. Negative 2 pi over 6 is negative pi over 3. Negative 3 pi over 6 is negative pi over 2. And I'm tired, so I don't want to go negative anymore. Okay? All right, let's put those red dots on. The first one I'm going to put on is negative pi over 3, negative 2. The next one is negative pi over 6, 0. The next is 0, 2. Then positive pi over 6, 0. And then positive pi over 3, negative 2. So this one's really close together because we've really shrunk our,
What does it mean though?
huh?
What's it mean by go over 2 periods?
I was gonna ask.
Over 2 periods? I'm about to show
Draw
you.
it twice.
Okay, that's the first period. Now it wants me to do a second period by extending it. So all I do is I just continue again in the same pattern. So from here, how many spaces are between each dot? 1. So if I'm at negative 2, my next one will be at 0, and my next one will be at positive 2, and my next one will be at 0, and my next one will be at negative 2. So there's a second period, and I'm going to dot it so you can see it. That's one I just extended, but it has to look exactly like the one before it. Does that make sense, you guys? Okay. So you just continue the pattern, make sure you put the proper spacing in between each, and you can do the whole up-down thing again.